Welcome, everyone. This is Anirudhha. Welcome to this presentation on credit card fraud detection using financial machine learning. This case study addresses the need for machine learning to detect the fraudulent transaction in financial sector, a pressing issue that cost organizations globally around $4 trillion every year. This case study explores the application of various classification models to distinguish between legitimate and fraudulent credit card transactions. We will delve into the intricacies of handling imbalanced data, selecting appropriate evaluation metrics, and fine-tuning the models to achieve optimal performance. Let us start with the introduction to dataset. This case study uses the credit card transaction from European cardholders over 2 days in September 2013. Out of 284,000 transactions, only 492 transactions are fraudulent, resulting in a highly imbalanced dataset. This imbalance presents a challenge for training the models as we need to avoid underrepresenting the minority class. And in the dataset, mostly for privacy reasons, most of the features are anonymized and labeled as V1, V2, and so forth. And our target variable class is 1 for fraudulent transactions and 0 for legitimate ones. This reflects a real-world scenario where data scientists often work with obstructed financial data to protect user privacy. The key challenge lies here in balancing the trade-off between false positives and false negatives. False positives can lead to customer frustration and increased operational cost, while false negatives result in financial losses from undetected fraud. Major consideration is dynamic nature of fraud tactics. Fraudsters constantly evolve their methods, requiring us to regularly retrain our models. Lastly, we must consider the privacy concerns and regulatory compliance while dealing with sensitive financial information. Due to the anonymized dataset, feature engineering requires some creativity. By leveraging the common knowledge of fraud, we enhance the model predictive power. We employ techniques like PCA or use feature importance scores from tree-based models to identify the most prevalent features. In this case study, we will focus on all the available features given initially. Then we will use the tree-based models to identify the most prominent features to train the model. Next, we will consider the model selection and evaluation. A range of algorithms are used from simple models like logistic regression to more complex models like random forest and gradient most, which often performs well on imbalanced datasets. Given high imbalance, accuracy isn't an appropriate metric. We may we may use precision recall and FL score to ensure sensitivity to both false negatives and false positives. And additionally, area under ROC curve metrics also help us measure the model's ability to distinguish between fraudulent and legitimate transactions. Finally, handling the class imbalance. Addressing the extreme class imbalance is crucial in the fraud detection. To achieve this, we simply apply undersampling on legitimate transactions to build the balance of can use synthetic minority oversampling technique to create synthetic examples of fraud cases. Ensemble methods are designed for imbalanced data such as balanced random forest classifier or easy ensemble classifier to further help improve the model sensitivity to fraud cases. However, in this case study, we will use undersampling to increase our model's accuracy. This is the final step of fraud detection by we deploy the best performing model, likely gradient boosting machine or random forest into production environment. This involves the model into existing transaction processing system to ensure real-time prediction. And also, we will also fine-tune the model using the best parameters which we can find using the grid search algorithm. Now let us move on to the code to see how it works in a Jupyter environment. Walk through the code for building a fraud detection model to classify the credit card transaction as normal or fraudulent. Our dataset contains transaction records by European cardholders from September 2013, and it is highly imbalanced, with only 0.127% of the transaction marked as fraud. This is a real-world scenario that requires careful handling of the data imbalance and selection of appropriate models. Now, let us go to the first step of our code by importing the necessary libraries which we are going to use. We will use pandas and numpy for data handling, matplotlib and seaborn for data visualization, and scikit-learn for building and evaluating the machine learning models. Specifically, we will be exploring logistic regression, decision trees, and some ensemble methods like random forest and ADA boost. Lastly, we will import module for saving our final model using pickle, which allows us to persist the trained model for future use. As you can see, our models have been successfully loaded. Now, next we will load the dataset which is being saved in the credit card.csv file using the pandas.read underscore csv function. As you can see, the dataset has been successfully loaded. Each column. As we can see, all the columns are mostly float, whereas class object is an integer type. Let us see how many classes are there for fraud and non-fraud. As we can see, we have only 492 fraudulent transactions. This is a highly imbalanced data set, right, with being most of the transaction being not fraud. So let us see let us see the histogram of the data. Distribution of the most variables are highly skewed. However, given the variable names are not being known, we are not able to gather any useful information from it. Let us check for any null values if present. Now let us check for the best features which will impact the selection of classification of the transaction, whether it is a fraud or not. As we can see, the features 17, 14, 12, 10, 16, 3, 7, 11, 4, 18 are most effective features. Now we will split the data into predicted value or dependent or independent values, where class is the dependent value which we will predict with the help of other values which we have taken above. Now, moving on to the model selection, we will try several classifiers including logistic regression, decision tree, and ensemble methods like random forest, AdaBoost. Ensemble models often improve the performance by combining the strength of multiple of all algorithms. We will also use the cross-validation to evaluate model reliably. Cross-validation splits the data into multiple subsets or folds and trains the model on each fold while evaluating on the remaining data. This process ensures that we do not overfit on any single data split. Now, let us see how our models are being performed. As we can see, these are all the models which we are trying to test. For now, we are comparing the algorithm with, as we can see, the accuracy of the LR algorithm is good. Every model has given above 90% accuracy, almost showing very good results. But given the accuracy is high, let us see how well it predicts the fraud case. Let us choose the cart model from the results above. We are preparing the model and see. And after getting the classification report, as we can see that precision recall, and let us plot the confusion matrix for the above evaluation or classification matrix. All the results are good. Still, 21 fraud cases are not being caught. So we should focus on recall, which gives minimum false negatives. Let us fine-tune the model by choosing the recall as a evaluation matrix. Again, after training all these models, we are getting some good results. As we can see, LDA has good recall of all these models. Let us use it to evaluate on a test set. Here, again, after seeing the classification report, let us plot it on a heat map. LDA performs much better, but still 18 cases are not, of fraud are not being caught. Additionally, false alerts, negative, positives are less as well. However, there are still 18 fraud cases in the test set which are being not caught. Let us try undersampling. Uh, Undersampling is a process in which we will remove the data to have a more balanced data set, thus avoiding our models to be overfitted. First thing how is to do how determine how imbalanced our class is. With the help of value count, we will determine how many instances of fraud cases we should bring non-fraud cases to the same amount as fraud cases, assuming we want a 50-50 ratio. This is equivalent to 492 cases of fraud and 492 cases of non-fraud, as we have did in this using this code. Now, after this, we have got a new data set in which there are 50-50 percentage of fraud and non-fraud cases. By show, we can get the count of fraud and non-fraud cases by using a histogram or a count plot. Now, let us use the accuracy as the metrics and retrain our models, all the models to check which model gives us a good accuracy or result. As we can see, now we can see all the accuracies which we have got. Let us compare the accuracies using a box plot. Given the best model as GBM, we can use it to further fine tune it using grid search. We will use the number of estimators as 20, 180 or 1000, max depth 2, 3, 5, and we will store the best parameters in the parameter grid dictionary and run the grid search and we will see the results. Here, as we can see, we are getting the maximum results with the help of max depth equal to 5 and number of estimators equal to 180. Using these parameters, we will again check how well our model performs. This is the classification report. After that, we will plot this classification report in the confusion matrix to better view the results. See, the results are really good. Only 9 cases are not being predicted as fraud. Choosing the right metric lead to an enhancement in fraud cases detected correctly. Undersampling leads to a significant improvement as all the fraud cases in the test set are being correctly identified post undersampling. Undersampling came with a trade-off too. In undersampling, our model is unable to detect large number of non-fraudulent transactions correctly. Instead of it misclassifies those non-fraud transactions as fraud transactions.